Hi, everyone. How are you? Good. Digestion going on? Huh? Great. So I'm Devis. I'm from Wageningen University. Probably you don't know where it is. It's fine. It's normal. It's somewhere in the middle of the Netherlands. And I was kindly invited here by Maisen and Maria to give a talk about geospatial computer vision, which is something that excites me a lot. So I wanted to talk about that. But then, when I was preparing the slides, I realized that before me, there was a keynote from ESA people, and I thought, well, maybe it's not a good idea to talk about how deep learning is revolutionizing the field, and maybe I can be a little bit more specific, because they will already have had a super good introduction about that. So I decided to change my title. So sorry if you've been lured into this talk by my lies, but we're going to talk about something new that we are actually doing in my lab, actually. And we are going to talk about how to talk to images, how to have some dialogues with satellite images. So something that, you're probably the second guinea pigs public I'm using for this, so just feel free to, shout and cry or participate in any way. Okay, dialoguing with images. What am I referring to? So the origin of this idea is that basically we want to do remote sensing accessible to people who are non-technical experts. So people who are familiar in looking into Google Maps, for example, but they do not really know what spectral bands are, but they want to know things about images and their content, okay? So it's people who are non-technical and they have very specific questions, and we are good at specific questions, okay? So if I have this image, and that's an aerial image taken from in America from USGS, and if you want to know how many cars are there in that image, it's okay. Most people here in the room can design a CNN with a loss of regression, going back and forth with your gradients, and in the end, having something that is more or less able to predict the number of cars. Good. But tomorrow, someone wants to know if there are trees in these same images. So, cool, okay, everybody in the room, given a training set, given a lot of time, you can design a semantic segmentation network or something like that, and having something that produces a segmentation map with the presence of the trees. And there we go, we can answer that question as well. Now, the problem is that very often you don't know in advance what's coming. You don't really know what people will be interested in, especially if people are not funding agencies that you have applied a project to, so they more or less know what's coming. But if it's journalists, if it's decision makers or things like that, basically you don't know what's coming and they want to ask you a question in English. They don't want to ask questions in convolutions. That's something that is unfamiliar for them. Okay? So basically, the story is that I would like something that, given an image, a model that is able to take on the fly questions and telling me the answer to those questions. That's something that we do every day. We discuss, you ask me a question, I give you an answer. Maybe it's what you want, maybe not. But we're all good at this. So I would like to have a model, deep learning based, able to do that. Okay? For just text, it looks like something like that. I don't know if you're familiar with this interface. Google. And basically, you are interested by deforestation, you write deforestation in here, you click Google search, and they give you, a definition, some pictures, some videos. Come on. How many Google search do you do every day? 500? Yeah, we're all guilty, it's okay. But if you take Google Maps and you do the same thing, you have an image of beautiful Wageningen campus, now you know where it is, and you write, is that a city? And Google Maps, it says, maps can't find, is that a city? So I can relate to that. Even I don't know if it's a city or not, but Google Maps is not built for that. So they're not capable of answering questions in natural language. The thing I would like to do is having a model that is able to understand the question and provide an answer that involves spatial reasoning, okay? That involves looking in the content of an image and give you what you want. it looks like that. So, okay, it's a preliminary thing, so I'm very excited to show it. But basically, at the very entry level, we have an image here. We'll see in a second all the key details. So we have an image, we have a question. For the moment, it's in English. I mean, we don't have a multi-language version, and they will be combined somehow, and they will lead to an answer. Okay, now let's go into a little bit of tech, but no time for the details. But an image, so taken by a satellite or an aerial sensor, we go into a convolutional neural net, your favorite one, and we'll give some kind of representation in vector form. The question will go into a neural network made for natural language, which will give another feature representation, and these two feature representations will be combined somehow, and the combination will be used by a very traditional classification network that will will classify your couple of image and question into one possible answer. Each possible answer is a class, okay? Yes, no, 1, 2, 3, 4, 5, urban, rural, car. You decide what are the possible answers. So that's the thing, okay? This is the model. If you want to know more about the specific model we use, there is a paper about to be released. So soon you will be able to see it. So the problem is that, okay, we have an input, we have an output, but we need to train a model. So most people in the room have been training neural networks, so you know that you need a lot of training example. So people in vision, when they do visual question answering, they go on Amazon Turks, they ask people, they show them an image, they ask questions, people give an answer, and they do that 1 million times. But they have a lot of money, I'm in Wageningen, it's a small university in the Netherlands, so we don't have all this money. So we thought, okay, what can we do? So first, images. Good, let's get some images that are for free. Thank you, Asa. Thank you so much. We have the Sentinels. So we took a set of Sentinels that covered the whole of the Netherlands. It's just 9 scenes. It's not 50 millions, but we can cut them into sub-scenes, and that makes 700 and something tiles. But now we have the images. Now we need to create questions and answers. And to create the questions, we used another thing that is out there for free, and in Europe is very good. It's OpenStreetMap. So we basically took every image patch we had, and started generating random questions using a pipeline like this. So we're looking in OSM which classes were present in the footprint. We were randomly generating some attributes, which would be like size, shape, relative position, things like that, and then randomly generating a question topic. And this will mean basically doing something like that. Creating graphs, they will say, road, count, make a question. So how many roads are in the image? Retail, size, present, question. Is there, size, random attribute, small, retail place in the image? And then they can become complicated with sentences that you will never imagine creating, but okay, we had to start somewhere. So by doing so, we ended up with 70,000 questions. Now, we have the Sentinel dataset is 70,000. We have another high resolution with 1 million image question answer triplets, so that makes a lot. And basically, if you have the image and you have the question, you have the answer for free, because you are querying OpenStreetMap for the question, and by the query you do, you can retrieve the answer for free. So if you look at, how many roads are present in the image, by looking into OpenStreetMap, you know the answer. So you can automatically generate the answer, which makes a triplet that you can use for training our model. If you remember, we need images, Sentinel, all right? We need questions generated automatically using OpenStreetMap, and answers also generated automatically using the same structure. Okay? Cool. Now, quickly some results, because I guess time is running out. How am I doing? Oh, you got 10 minutes. Oh my God. Okay, cool. So I can take my time. Whew. So let's go back to the question repartition. No, it's great. I thought I had 15 minutes. I still have 15 minutes. So the questions, we tried to balance them a little bit because, if in VQA literature, visual question answering, there is one thing that always puzzles me is that if I ask you a question that starts by "is there?" the answer is yes, 99% of the time. So we had to, be careful not to have these biases in our data set. So we tried to keep a balance between comparisons that will be, is there bigger than that, for example, which gives you a yes or no, and having counting questions with numbers. So how many trees, how many cars, how many this, how many that. So we tried to keep a distribution that was not too much concentrated on yes/no questions, but still respecting what happens naturally in natural language. So yes, more yes or no question, but not just dominating. Otherwise, your model doesn't learn anything. It basically just learns yes or no, or the rest. Good. So we go back here. So some results. We were pretty excited when we had the first results because, on the 77,000 triplets data set, we had roughly 80% accuracy. It's like, wow, it was great. And so that was my postdoc. So he's not here, so I can blame him. And I told, yeah, but let's just try, randomizing the image part to see if the model is actually using the image or if it's just inferring the right answer just because it looks at the question. And then we were a little bit less happy. So looking only on the text, it goes roughly 70%. Text plus images, it goes 80%. So, it's not, as usual, no deep learning, silver bullet, not true. It's using the image, but not so much. There is still a lot to do. And where we are actually not very good are the counting questions, okay? So I think that's where there is still something to do. But, finding rural versus urban areas easy, probably given to the difference in reflectance, and the presence-absence seem to be okay, and so on. One thing that the model does very well is stay in the right type of question. So if the answer is to be yes or no, it will not say 1500, which is nice. At the same time, this is the job of the module that analyzes the question, so the natural language processing. So that part is doing a good job. When you need to predict a number, it predicts a number, and it makes mistakes in there, and it doesn't say yes if I ask you how many cars are in the image, which is something that we will never do as humans. So that's great. So a couple of visual examples so that you see more or less the size of the scene. So here the question was, is this urban or rural? So the model predicts correctly. I guess it sees a lot of green, so it will tell rural. It is a comparison question. So do you have more water or more buildings? So all this is water. It's very dark, but so good. The model does all right. Urban or rural again, you have quite some buildings here, so it makes it all right. But of course, 80% means that 20% are mistakes. And we looked into some of these, and this is one that I think can trigger a good discussion. So this complicated question is, are there more water areas than commercial buildings? And if you look at the image, you see all these buildings here. You don't know if they're commercial or not, but definitely they are more than water areas. So why is the ground truth, is our prediction no? And the funny thing is that then we looked at the data that was used to create the ground truth, and this is the problem of sub-pixel resolution things in the image. So of course the big canals, so remember we are in the Netherlands, so we have a lot of canals, so these guys are there and visible, but then you start to see very small water areas, like canals that are maybe that large. And these things are subpixels, so they are not visible in the image. So the model looking at the image has no chance of finding the right answer because also these little ponds, they are not visible in the image at all. So this also tells you a little bit of the limits of generating a huge data set in an automatic way without showing the question-answer pairs to humans. Is that this is the limitation. You can see something in the image, but you see it in OpenStreetMap, so you get a ground truth that is wrong, and your model learns wrong. Okay, anyway, to conclude, I just wanted to show a little bit the thing, so where I would like this to go. So Anyway, let's play a game. I like to finish on a game, so to finish your digestion. So let's say I would like you now to tell me what you want to know about this image. And I have a bet with a colleague that I can guess what your questions are. So let's see. Who has question number one?
What's that building?
Yes, number one. And I cannot lie because the slides are pre-done, so there is not my colleague writing the text in the back. So okay, I rephrase it. Where is it? What is this building? It's exactly the building you are in. So it's here. Yeah. So that's the VQA system. Now you ask a question, and the machine. So here the little robot with the nice bulbs, it'll tell you, make some geolocalization and tell you, okay, your coordinates are this. You are in a PFL. Go. Good. Second question. Oh my God. Yes. we don't know each other, just to be sure. We don't know each other. Thank you. So how many buildings? And I want the exact same model without any retraining. So I want the same machine to understand my question and tell me 57. Okay? I don't know if it's 57. Just make that up and don't start looking on your smartphones to see if it's 57. The third, I always get it wrong. So let's see. Question number 3. Take question number 3. Okay, another shot. Sorry? Oh, I should have put that one. No, okay. Because I already had the question about how much. I didn't want to do many. So my third question was, which one of these buildings are new? I mean, it's a fair question. No? And I would like the same machine with maybe with a little bit of retraining. I don't know. I mean, that's like some future stuff. To understand that my question is about change. And I would like the same machine now to understand this, go in and fetch an image that is older, starting to make some comparisons. So look up and down and up and down, make some change detection, something, maybe another deep net, who knows? And at some point tell me these ones. Now fix your eyes to the one you prefer. It doesn't matter which one, and I will still go a little bit so you can see the changes. All right, and that's more or less the idea. It's something that, is food for thought and food for the future, but it allows me to finish this talk, and I thank you for your attention. I hope that you like the idea of visual question answering for remote sensing, and maybe one day we will have a visual search engine that will make use of satellite images. Big thanks to my team that some people in the room know, because some of them started here at the VFL, which is funny. And thank you very much, and enjoy the rest of the conference.
We have 5 minutes for questions.
5? Oh my God. Good. Hey.
How do you deal with not well-defined questions? Which ones of these buildings are new? What does new mean?
But for the moment we don't. For the moment we have full control on the generation of the question because we generated them ourselves. So very, very important question for the future, especially another thing that bugs me a lot is that by creating the question ourselves, okay, we have full control, but our grammar is super poor because all the questions are asked in the same way, and it's not as rich as how humans would ask questions. So, this definitely work for the future. Yeah.
I think what you showed us was learn from end to end.
Yes.
How do you see it with having some pieces, something a bit more distributed and learn not end to end, but piece by piece? Do you think it makes sense or it brings blockers?
In the current setting, I think it makes sense to learn it end to end, especially because we're using some pre-trained stuff. So it's more, the only thing that we have to learn is this in the end. Yeah. Now, say that if you make the monster more complex, for example, you would like to answer different types of questions, some that will, where you will be satisfied with an answer that is a word, or maybe sometimes you want to have a map as an answer and you need to understand which type of question has been asked. In that case, yes, then training in a modular way will make more sense. For this, it's fine.
Do you use the same neural network architecture for all types of questions?
Yes. Yes.
Do you think it might be an idea to use different
So I will give you the same answer. In the current setting, all the questions all the answers are considered as a single answer vector, no? So they must be handled by the same model because the image goes in, it needs to extract these features. The question will go in, we answer the feature, and the only thing that differentiates is at this point. So for the moment, we're not making any attention mapping, for example. In that case, you start to have the need of something different here. But for the moment, there is just no need to make this differentiation.
How do you deal with there's no answer and then you have the counting question?
Yes.
So the accuracy is lower.
Yeah.
But that's kind of more of a regression task. So what was the error when it was miscounted?
So, very good question. In this specific study, it was considered as a classification problem because we have a big variability in the number of possible answers, and it's power law distributed. So you have a lot of very small counts, but just a little enormous one. So we basically binned in a logarithmic way. So
When it was wrong by an order of magnitude.
yes. Yeah, but now we're working on considering the counting as a regression task and having a look on how it works. And then, I don't have the numbers on the top of my head, but I can look it up if you want, yeah.
All right, we have time for one more short question. Nobody?
Or not.
Is there going to be any support for other languages?
That's a good one. I think going multi-language will be a good point to making the language part a little bit less rigid. And yeah, we're both French speaking, a bit of English. I mean, I could do the Italian part, but it's definitely in the pipeline. The truth is that the language part is not our expertise. We're more remote sensing people, so we're a little bit unsure how to proceed. This model that we are using is optimized for English, so we will have to I'm sure there is a version for German, but we just have to look it up. Yeah.
All right, let's thank Devis again.
Cheers, take care.